now request Mr. Ajay Singh, Superintendent Engineer, Maharashtra Jeevan Pradhikaran, to please come onto the stage. Can we have a round of applause for him, please, ladies and gentlemen? Warm welcome, sir. Very good afternoon.
Aman Mittal sir, dignitary present on dash, Aman Mittal sir, Arvindji and all the delegates. In fact, I have been told in last moment to tell something. So I am very happy to thanks to organizer to give me chance. So just I would like to say what we are presently doing in the Maharashtra Jeevan Pradhikaran. So this is the first time that we are doing with the help of the Jal Jeevan Mission program. So first time we are doing IoT in the rural areas. In fact, Maharashtra Jeevan Pradhikaran is doing around 929 schemes. Out of that, 389 are the multi-village schemes. Some schemes covering the more than around 389 villages, like that, 389, 150 villages, 160 villages. So first time we are doing the IoT part in these multi-village schemes. In IoT part, basically aim is to measure, start from the source to the end, like how much water is going on. Then from the overhead reservoir, from where the water supplies to the villages, so we are measuring the quality also. So which what is the turbidity, pH value, and all the parameters, and then how much quantum of water is going to supply every day. And at the end of the distribution system, at the highest place, we have the sensors. So we are planning to put the sensors so that we can meet whether measure, see that whether the villagers are getting the water with the proper pressure or not. So and all this data this type of arrangement is going to be made, that all the data we are going to see from our head office. So whether how much water is supplied, which villages are not getting the water, whether good quality of water as well as quantum of water as decided by the Jal Jeevan Mission. So this is the first time we are doing this in Maharashtra, probably in India, in rural areas. Second thing, what we are doing is we are making all the multi-village schemes around. It's 380 multi-village schemes are there, which is being implemented under Jal Jeevan Mission program on the GIS platform. Like all the water networks, all the component we are bringing on the GIS platform, not only for monitoring purpose, but also for the asset management purpose. Because we are creating the asset, but it is not being maintained. So first time we are doing all the component in the GIS based things, and that is going on. Probably in the next 3 months we will do the monitoring of all the schemes on the basis of this digital model developed by this one. So this is what we are doing in rural sector. Now, as far as the effective water management is concerned, so how technology can benefit in the, so what I see, that one very important thing that we are not following in India is the measurement of water. When I went to the Israel, they told that even the private bore, if someone is taking water from the private bore, that is also being measured, and they do the proper water audit. How much water has been taken from the private bores, groundwater, but in India we don't have we are not measuring. Even if someone asked to show us how much, what is the NRW of the particular city, so we don't have the meters. We don't have the meters at many places in the consumer meters, so we cannot measure correctly all the things. So measurement is one of the very good tools for the effective water management. Now, as an engineer, I just give one. Someone is Niger, someone is there, because now we are talking about the smart meter, but we have already the mechanical meter in place in different cities. Like Amaravati, we are maintaining, so 100% meetings are there, but they are the mechanical meters. So is it possible to convert this mechanical meter into the smart meter in place of the changing all the mechanical meter with the new type of smart meter? So this is one of the challenge if some technology industry comes with some technology that it can be changed with a very low cost, so that will help us a lot. So just because we have already meters in the different cities, different urban areas, consumer meters are there. So and why in fact metering is not going to progress, because everyone is saying that we should go for 24/7, we should bring the smart meter, but this smart meter is very costly, around 10,000 rupees like that per meter cost, and people are not able to bear. So wherever the meter we are having, mechanical meters are there mostly, so can it convert into the digital side? So one of the if technology will help or industry will help in that, so that will obviously we can utilize the existing resources of these things. Mittal sir has already told about the Marathwada grid. So we are doing this is what I have seen we have seen the Australia, because Australia sir, there are 12, they are taking their ACQ grid, South Eastern Queensland grid. So they are taking water from the 12 dams, as well as one of the desalination plant around 100 MLD, and high yield borewell also. So with the help of this technology, so they are maintaining all the system very nicely. So on the similar type of things, we have developed a Marathwada grid in the Mittal sir told that it is obviously it may happen. We are pursuing it with the different government level and World Bank level also. So what is there in, just I will tell you, in Marathwada, in fact, what is there, some area of there are 12 major dams in Marathwada. Jaikwari is the largest, one of the largest dams, in fact, in the third largest dam in the Maharashtra. But what happens, the catchment area of like Jaikwari is the Nashik area, Nashik side area. Catchment area of the this Ishapur, Upper Penganga dam is the Bidarbha area. So all dams are not filled at a time. Some dams are filled in this year, some dams are filled in this year. So what we are doing, we are just making a loops of all the major dams. And here we are making the bi-directional arrangement. If some, like I have to take the water, design the system like that, I have to take the water from this dam 100 MLD, this time 100 MLD. So 100, like 4 dams we are taking 100 MLD from each dam. Suppose in a particular some dam doesn't have any much water, so that 100 MLD can be distributed from the other dams also. So in that, here we have developed a system of bi-directional flow also. So this is a very good things we have designed, and all the things with the help of the Makerot, which is the Israel-based company. And as far as the urban area is concerned, the presentation made by this Astoshji, so that was very nice in fact. And but what we feel that what the like we are doing the hydraulic modeling, but we are not the replicating the things what the behavior is doing on the field. In fact, I have tried. I was in Ambernath. I was posted in Ambernath. I was doing the modeling. So I was measuring. I was putting the pressure, how much pressure is in this pipeline. But when I was running the hydraulic model, so pressure was not matching with that. So reason behind that, I later found that some people are taking more water on some the pipe. Maybe the C value of the pipe has not been correctly matched. So what the real behavior of the field is there. So we are not matching with doing the hydraulic modeling. Just we are doing the design, but we tell that we are doing the hydraulic modeling. So this type of things should be also popularized and done. So and I'm not prepared well, so just so thank you very much. Thank you. I will like to thank the organizer who give me the opportunity here to present. Thank you.
So sir mentioned that this was not a prepared speech, it was just impromptu. I think that definitely deserves a huge round of applause. It did not look unprepared at all, sir. Thank you so very much.